Hello everyone, this is Abdurrahman Fuad from PetroNile Academy with a warm welcome to our first webinar, Optimizing Reservoir Performance and Recovery Rate by Mr. Taj Uddin. This webinar comes in collaboration with the Petroleum Engineering Association. Thank you for taking time out and being here today. But before proceeding to Mr. Nikhil to present our esteemed guest, let me give you a brief about the Academy. PetroNile is a non-profit e-learning platform with a focus on oil and gas industry, targeting to provide students and professionals with practical knowledge in the wide areas of this sector. We will have a live Q&A by the end of this session. So if you have any questions, please write it down in the chat section. Now I'll pass the mic to Mr. Nikhil from the PEA.
Thank you so much, Mr. Rahman, and very good morning, good afternoon, good evening to everyone. Thank you so much, PetroNile Academy, Organic Oil Recovery. First of all, I welcome Mr. Taj Uddin. He is a graduate in Petroleum Engineering from UCSI University, Malaysia. He has acquired technical skills in fundamental engineering background, already gained some experience as engineering intern in Dea Maxlow, Asrian PhD. He was also student laboratory assistant in drilling engineering laboratory at UCSI University under the University Scholarship Program. In this duration, he has learned technical and non-technical skills like mud testing, management, and organizing skills. He was president of the Society of Petroleum Engineers UCSI University Student Chapter in the year 2017-18. Besides this, he participated in several talks, events, workshops, trips, where he learned the importance of time management, presentation skills, teamwork, communication skills, and interpersonal skills. At this time, I would like to tell that there will be an open Q&A session where you can write your questions related to the topic. Now, I would like Mr. Taj Uddin to start this webinar session. Thank you, sir. You can start.
Hello, good morning, good afternoon, and good evening, everyone. Thank you so much to PetroNile Academy from Sudan and Petroleum Engineering Association from India. And thank you so much, guys, for taking out the time and organizing this session. It's not really easy to do this kind of volunteer activities in this pandemic. Thank you so much. My name is Taj Uddin, and I'm an operation engineer with Organic Oil Recovery based in Dubai, UAE. Basically, I take care of all operation on the field and also in the office for Middle East, Asia, and Pakistan. So today, our topic is optimizing reservoir performance and recovery rate. So we will talk about this one by organic oil recovery, which is a unique and a new enhanced oil recovery method in the market. So the content of the presentation will be the science of organic oil recovery, the process and mechanism, the H2S reduction, and then I will share some recent pilot test data from North Sea, Canada, and US. And then there will be a Q&A session in the last. So basically, what is organic oil recovery and where and what we currently working on? So first of all, I need to clear this, that organic oil recovery is a unique and new enhanced oil recovery, which we call EOR. So this is very different from Microbial EOR, which is already in the market. And currently we are very busy in 3 continents, 5 regions, Middle East, US, Canada, Australia, Malaysia, and Pakistan. And we have 160 plus sample in the lab. Our lab is based in California, and we are undertaking field production from 600 to 130,000 barrels per day. So it's from small field to big field everything in between. And we successfully completed 400 plus application with 60 plus oil field around the world. So basically, where this organic oil recovery technology came from and what is the science behind this? So organic oil recovery is from the name, it's already clear that we are using organic nutrients and organic components in this one for the recovery of enhanced oil recovery. There is no chemical or nothing, no chemical is used in this one. So 15 to 20 years before, the scientists didn't believe that the microbes or the microorganism live on down the earth. But after 15 years, the research has done that they can see the microorganism live deep down all these layers in the sedimentary rock where the oil and gas can trap. And they can use this technology, these nutrients, to recover the oil, which is already a trapped oil. So now we will see like what is the science, what do this organic oil recovery do? So actually organic oil recovery is a unique method which they use neutrons and inject into the oil reservoir, and they just manipulate the existing microbiology of the reservoir. So we are not injecting any bacteria, we are not injecting any foreign bacteria to the reservoir, but we are just manipulating the microbes which is already exist in the reservoir. By this method, you can increase the production increase through applied microbiology, and also this can reduce the H2S as a side benefit and increase the oil production using only residence microbiology. So we are not injecting any foreign bacteria from the surface with like what we do in other microbial EOR. And this technology is one of the cheapest EOR method in the market, and this reduce H2S as a side benefit. And globally, we have 400 applications over 4 continents. And this is a true enhanced production by releasing the trapping oil, but not only accelerating. So now there will be a question that what is the difference between microbial EOR, which is already in the market from many years, versus organic oil recovery. So we are very different from microbial EOR. So microbial EOR, they are injecting foreign bacteria to the reservoir, and sometimes they are injecting some sugar-based nutrients by plugging the reservoir or pores. While in OOR, we are not injecting any bacteria, but we are injecting a special nutrients, which is organic totally. And with the help of that, we recover oil. So microbial EOR, they have like a mixed track record. Sometimes it's like hit and miss. It's like a 50-50. Sometimes it's work, sometimes it's not work. So they have like very mixed record of microbial EOR. But OOR, they have 94% treatment of success rate. MEOR is generic, and they introduce foreign bacteria, and they have a several issue like plugging, and they use sugar-based nutrient, and due to aerobic, they are feeding all the bacteria, the good bacteria, the bad bacteria, which is present in the reservoir. And these bacteria can cause a lot of problem in the reservoir, like corrosion, H2S, and all these things. While organic oil recovery, they are only focused on certain bacteria families, which we call a good bacteria, and we are not feeding everyone. And by this, it can reduce the corrosion, and we can eliminate the SRB by out-competing. So organic oil recovery, organic oil recovery is 100% organic, environmental friendly, and they have a stable production from 1 to 3 years if you apply the treatment. While the MEOR, they have a short live production spike. It's work just for some time, then you need to feed again, then you need to feed again and again, and it's cost a lot of money. So actually, if we do comparison between OOR and other EOR technology, like chemical injection gas injection, chemical EOR, gas EOR, thermal EOR, all these things. And then we compare with the OOR organic, which is the new technology here, the new EOR method. So with the other EOR technology, you need a large capex. You need a lot of money to do the subsurface modification. You need a lot of equipments to buy for this one, for injection and all these things. But in OOR case, operationally, it is very simple. You don't need any capex, no extra money. What the operator have, that's what we need. We just need an injection pump to inject the nutrients. With other OOR, you need 2 to 3 year implementation. From planning to execution and then implementation, it's take a long time. With the OOR, you just need from the start of the meeting to the implementation, it just take from 4 to 6 months. With the other EOR, you need to inject a large volume of chemical or product into the reservoir. But in organic oil recovery case, we are just injecting a small amount of nutrients. No need for the topside modification in organic oil recovery. There is no disposal or aquatic issue because it is 100% environmental friendly. So the nutrient is like a kind of fish food. You can dump just to the sea. So there is no environmental issue of that. So this is the unique thing, and this can solve a lot of problem in offshore, especially because especially in North Sea and America, there's a lot of environmental concern, and you cannot dump these kind of nutrients easily to the sea or on the land actually. So that's why this get a big advantage on other EOR methods. So basically, this is the science that how this microbe its work actually, how this oil can recover, how this OOR can help to recover the trap oil or the oil which we call the residues oil actually. So if we see the first test tube, we took some water and oil as in a separation phase, and actually the microbes naturally they are in the water phase 99.9% most of the time. They are liking water, which is called hydrophilic. And when we inject the nutrients here, so these microbes, we change their status from, they just go from the water to the oil phase actually. They just become hydrophobic. They don't like the water, but they go anywhere which is not water. So in this case, which is oil actually. And this test tube, 1 milliliter of water contain 10,000 microbe per milliliter, but after the injection of the nutrient, these microbe manipulate and become a very large number, which is 100 million per milliliter. So this is so basically what we do, we just increase the number of microbes, the good microbes, which is inside the reservoir, and just manipulate and become a boom up a large number of million and billion of microbes in the reservoir just in hours in time. So basically, if we see there is a two phase, which is this is the oil water interface. The microbes will just go from water to the oil, and this will come to the surface and also and down, and by physical interaction, these oil drop is converted into micro droplets, and these micro droplet can easily move to the wellbore, and this how it can recover more. And if we see here, this is with the water actually, and it's changed the intervention force, and the trap oil, which is already trapped, it can convert it into small droplet. By small droplet, they can easily move to the wellbore, and that's how they can release the oil. So in today, the oil industry and the primary and the secondary, they just recover up to 35% of the oil, but still 65% of the oil reserve is not recoverable, or it's not economically recoverable. So there is a huge market for EOR presently, and also this technology can apply in the brownfield. Brownfield mean which is already the production is going to decline from many years, or it should be applied in the greenfield, which is like the production they just started now. So this technology can be easily implemented in the brownfield or in the greenfield. So this is the picture of water, the produced water, and we can see the microbes under the microscope. This is before the treatment, before injecting any nutrient, and this contain 10,000 microbes per milliliter. And when we inject the nutrients, this is how it's look like 100 million microbes per milliliter. It's look like this in under microscope after the applying the nutrients. So basically, this nutrients it's caused the mitosis process, and it's multiply the number exponentially. It's change the number of microbes in minutes and hour and days, and it's converting like to billion and trillion microbes, the good bacteria, deep down the reservoir. And these bacteria do movement, and due to that movement, with the physical interaction of oil drop, these oil drop can convert it to small droplet, and these small droplet can easily move to the wellbore, so which basically increase their mobility. So by applying the OOR technology, so it's one of the benefit is it will increase the production, but another benefit is, you can say side benefit, this technology can reduce the H2S reduction. So it is like a one treatment, but which can give you two benefits by reducing the SRB by outcompeting actually. So basically with this technology, this is the only technology, they can increase the production and also decrease the H2S by eliminating the SRB, sulfate reducing bacteria, which is already present in the reservoir, or sometimes it's coming from the injection water. And these bacteria, the SRBs, they are producing the H2S, and H2S is very danger gas and oil reserve, and they can cause a lot of corrosion and deep down, and also it's not good for safety wise. So with the organic oil recovery, so the good bacteria basically eliminate the SRBs, and the SRBs finally go die in the reservoir, and then there is no H2S. So it's automatically the H2S will reduce. So these are some of the examples we did from the field, and so in 5 months from March to August, and we can see that the SRB was the H2S was reduced by 33% in this field. And basically, so the reason was that the SRBs was outcompeted by the good bacteria, and the fuel was from the source, it's become a sweet, so it's a sweet oil they are producing. So basically, the organic oil recovery is a 5-step process, that how this technology works from the starting of the discussion to the implementation of the full field. So basically, it's very easy to have a field screening of the reservoir characteristic. We have our own parameter of the reservoir. By doing the screening of the reservoir, we can see that this field will work or not. And then when we say that, okay, this well will be working or not, we take a water sample only. We are not taking oil sample, we will only take the produced water, and we will analyze that produced water and laboratory in California, or microbiologists and scientists, they can study by applying different nutrients, and then they can see that this nutrient and this fuel will work, the production will increase or not. And when they satisfy that it will work, then we can go to the pilot test. So basically, the pilot test, we will go to the well and we will inject the nutrient, and this is by hub and pump process. And after that, we will do the well test, and then we can see that how much is the technology work or not. So I mean, the worst case scenario is that the technology will not work, but we have 94% success rate. I mean, we didn't see that it doesn't work. Sometimes it's just produce very less oil, but most of the time the production will be increased 100 to 1,000 times. And then when this work, so this technology is basically ideally for water flood field actually. So if there is the water injection, so this technology will work 10 times more than on the produce well. And when it's worked there, so you can implement on the full field. You can apply this technology in full field. So for the organic oil recovery, we have a sweet spot. We can see that either this well or the reservoir will be working under this technology or not. So we have a very wide range of oil gravity we can see from 12 API to 42 API. If the oil API is from 12 to 42, this technology will work. And the water pH is from 6 to 8, which is quite neutral. The reservoir temperature should be less than 105 degrees centigrade. The more the temperature, then the reservoir become very hot, and actually normally the microbes become very inactive, or maybe it can die. So the optimum temperature is 105 degrees centigrade, and the produced water salinity should be 2015 ppm, and the reservoir permeability greater than 1 millidarcy. The higher the better. And for this kind of, we need all the information. The more information, the better it is to do the field screening and prepare the best nutrient for each well. And remember, each well have a different recipe. So it's not like we have one recipe. So we have like more than 500 recipe, and you can, it's a complex recipe, and you can apply on, so different well and different reservoir have different recipe basically. So basically it's very simple. If you go, so for the taking the sample, we have this jug, we just collect the fluid from the wellhead, and then we keep it for separation. And when the water and the oil is separate, we can collect the produced water and the bottles, and then we dispatch it to the California, to our lab, and then they can do the lab analysis, which they can analyze the RNA, the DNA, and they can see, and they can see all the microbes that this reservoir have, what kind of microbes and what kind of bad bacteria they have, what are the good bacteria they have, what are the families, and all these analysis, and then they can prepare the recipe base for that one. And when the customer, when the operator, they are okay with it, so we can go to the pilot, and then we can inject very small amount of nutrient. It's from 1,000 liter, which is very small amount of nutrients to inject in the well. Normally the chemical EOR, they are injecting 1,000 of balers per well actually, but here it's only one baler, or maybe 2 baler, or maybe maximum 3 to 4 baler. So it's a very small amount of nutrient you are injecting, so you are not disturbing the reservoir too much. But in other EOR, you have the issue. There should be a risk if you are injecting too much nutrients from the outside or chemical from the outside, so you are disturbing the natural zone actually. So basically, we have recently a pilot test from North Sea. So this was operator. This field was operated by CNOOC. CNOOC is operator in North Sea. This Scott is very famous oil field present in UK continental shelf. It's a mature field producing since mid 1990, and this is a Jurassic sand. So this technology, the organic oil recovery, is basically working in both formation wise. It's work in carbonate and also work in sandstone. But microbial EOR, it's highly work in sandstone, but it's the success rate and carbonate is very less. So basically it's working in, but this organic oil recovery, it's working formation wise in both. And the bottom hole temperature of this field was 94 degrees centigrade, and it was a high water cut field basically. It was around 95% the well was producing, and actually the total production was around, the total production of that well was around 10,000 barrel per day total fluid, and with the 94% of water cut. So it was producing around 9,000 barrel of water only. So it's not very economical basically. And then in the UK, and especially in North Sea, you have these regulatory, so you cannot just dump the produced water into the sea. You need to clean that produced water and then circulate, or you need to inject back. So there's also cost on each baler you are producing. It's not like in other part of the world, like mainly in Asia, especially in Pakistan, India, and maybe in Africa, you can just dump the produced water. But in North Sea, they have like a very strict environmental regulatory. You cannot dump these produced water to the sea directly. You need to clean that water because they contain a lot of chemicals, and it's not good for the normal life. And then the pilot injection was implemented a few months back, as in June 2020, and it was a huge success actually. And we already released our case study on our LinkedIn page and also on our website. So basically, so these are the results. So if you can see my graph, if you see the screen, and you can see the graph. So vertically we have the oil production, okay, and here on horizontal we have the time. So if you see this one, from on the left side, this was before the pilot test, before injecting anything, and the well was producing, and then it was going to decline. And if we extend this one, so after some time, this well was going to decline here. But if we, so then when we inject our nutrients, and we restart the well, and we did a well test, so they get 25,000 barrel incremental on only one pilot test from the producer, and the H2S was reduced 33%, and a return on investment they got more than 1,000%. And also the water cut was dropped by 4%. So 4% is a huge number for this kind of big well. And now this company, CNOC, they are going for full field application next year. So they are very happy with the results. It's a huge success for us as well, and as also like very good for the operator actually. And the best part is that whatever they invest in this project, this project payback was only 3 days. So they get the whole investment only in 3 days, and after 3 days, still now they are making profit of this small pilot test. This is only a pilot test. The pilot test means you are going to check that either this nutrients will work or not. It's a very cheap and very low cost technology to implement. And now the UK government and the UK Oil and Gas Authority, they already approved this technology that they can apply and on all their offshore asset basically, because they are going to decommission that one. So this most of the oil field in UK continental shelf are brown already. So they are producing from many years, but now it's going to decline phase. So this technology can give a life of 10 years more to each, like a lifespan of 10 years to each field actually, which is going to decommission. So this is still there is a lot of residuals oil which need to recover by applying this kind of technology. So these are the graphs of the water cut. So this was before the treatment. The water cut was going increase, and then this was a sharp drop in the water cut. So it's a 4% water cut, which means it's like 100 of better of water cut they can. So they don't need to extra treatment on this water, produced water per barrel. So basically on this project, there was zero capex. I mean, there was no topside modification of subsurface facility. There was nothing extra. Whatever they have, the equipments they have present on the platform, that what all we need actually for this kind of technology. But with other EOR methods, you need a lot of equipments and a lot of pumping machine and all these things to inject basically. And significant incremental oil gain, which was 25,000 barrel incremental, and this was the lowest water cut since in last 5 years basically. And the best part is that with apply OR, there is no change in the oil quality and separation efficiency. So the oil you are producing after the treatment, it will be the same as it before. So this is one of the good thing they have. And also observed drop and H2S. So basically, organic oil is they have two benefits. One is they increase the production. Another, they reduce the H2S significantly. So it's like a two benefits with one treatment. So these are the results we get from Canada. In one field they apply on the full treatment, and if we see, So this well was actually, this is the decline curve before. So I mean, basically before the treatment, they already, the company, they predicted their fuel will be declined like this way. This is the original decline rate. But when they inject the nutrients, so it's a batch treatment actually. Batch treatment means you can inject nutrients, and then the nutrient will do work for a certain time. Then you need to inject the nutrient. Then it will work for a few months, and then you need. So you don't need to inject continuously throughout the time. So this, some of the chemical EOR, you need to inject continuously, like polymer or surfactant. You need to inject continuously a huge amount of nutrients, and that is the reason they are disturbing the reservoir deep down too much. And when they did the treatment, so you can see the post-treatment decline curve. So it's increased. So area under the graph is the what they recover and what they make the extra money actually here. And this one we have from California, and the same result we get for the 3-batch treatment. So this is the field, and we have a lot of SPE paper, 6 to 7 SPE paper we have published. It's already available on our website for more information on the production numbers on the field. And we have 2 SPE papers coming next year. One will be coming from the North Sea, the result which I show already, and another one will be from the Middle East. And currently we are getting a lot of attention and going very busy. And to implement the OOR is quite cheap actually. So this is a very low cost technology. Even its work for it's still beneficial for the operator, even if the oil price is 30 um, 30 USD per barrel. So it's still profitable at that kind of low oil price actually. So thank you so much, and thank you so much to all of you for listening. And I hope I share something, and I hope you guys get some extra information. And if you have any question, actually, you can ask here. We will try to answer here. In case if you have any inquiry, you can reach out to us on this email, and you can contact us. You can join us on our LinkedIn page, and also you can see our company page, website actually. And if you guys are worry about the SPE paper, so these are the SPE paper published by the operator, and you can find all of them. And also you can find the case study and all news on our website at organicoilrecovery.com. So thank you so much once again. Now I will pass the session to Nahil, and then we can go for the Q&A session. So yes.
Thank you, sir. So participant, if any question, you can just put in the chat box.
Or maybe they can ask here if it's possible for them. If they cannot write, so they can explain here, and then we can try to answer from here. Anyway, I mean, it's either way will be possible.
Sure, sir. You can take the questions from the chat box. Otherwise, I can tell. So first question from Elijah. What exactly is the microbes that you are injecting? Can you name some of the consumers that you create those microbes?
Okay, so actually I already mentioned in my presentation that we are not injecting any microbes. So basically what we are injecting is a specialized organic nutrients, which we call kind of a fish food for that microbes which is already exist in the reservoir. So basically we are manipulating the microbes which is already residents in the reservoir. So each reservoir have different type of microbes. Now there is like millions of different microbes present, different families. But we are targeting certain families, which we call a good bacteria, actually good microbes. So once again, so we are not injecting any foreign microbes from outside. We are just injecting nutrients.
Okay, sir. Let's go to the second question.
Yes.
Sir, what are the difference between organic oil recovery and enzyme treatment enhanced oil recovery?
Sorry, please, can you repeat the question?
Yeah, sure, sir. So, what is the difference between organic oil recovery and enzyme treatment enhanced oil recovery?
Okay, so organic oil recovery is 100% organic, environmental friendly nutrients which we are injecting into the reservoir to manipulate the special kind of bacteria. While the enzyme or the green zyme, they are basically based on enzyme actually. They are injecting enzyme from the outside. So it's very different, but somehow they work on both way. But it's depend on how successful the enzyme they are, because there's also other EOR method like polymer injection or chemical injection. So these are the difference actually. They are injecting chemicals, but what we are injecting is 100% organic nutrients. So this is the main difference.
Thank you, sir. Next question. Sir, if you don't use microbes, what would be the main driver of organic oil recovery?
So we are targeting the microbes which is already present in the reservoir. So for that reservoir, so actually each reservoir they have their own microbes present inside. Okay, so by getting the sample, we find out that which microbe this reservoir have present, and then we create a special recipe for that microbes to manipulate that microbes to stimulate that one, and so we are injecting nutrients. That's why. So actually, basically, microbes are the main driven for the organic oil recovery. But we are not injecting microbe the foreign. We are not injecting microbe from the outside like the other MEOR. In MEOR, we are injecting foreign microbes to the reservoir, but in organic oil recovery, we are injecting nutrients and to manipulate the microbes which is already present in the reservoir. So basically, we are targeting the microbes which are the residents there. We are not injecting or not introducing any foreign microbes from outside. So this is the main differences. And and microbes are the main driver for recovery with the physical interaction.
Thank you, sir, for your answer. So, next question from Emmanuel Callisto. Sir, condition required for oil displacement and mobilization on enhanced oil recovery. What are the conditions required?
So basically, we have this OOR sweet spot for each well or each reservoir. So we can go to the field screening characteristic, and we can see that the condition of the temperature, the main one, the water, the salinity of the well, and also the permeability, which I already mentioned in the presentation. And so basically, the residues oil, or which is the droplet oil, these microbes just go around that one, and they can basically convert these droplet to micro droplet. And when it's when it's converted to micro, so they can easily do a movement because there is no resistant force, and they can easily move with the water path to the wellbore side. So it's a very simple mechanism, nothing fancy, nothing rocket science, very simple. When the size of the oil droplet reduce, it can easily move. Fluid dynamics.
Okay, sir. Thank you so much. The next question from Angelus. Sir, what are the oil and gas companies in the world which are currently using organic oil recovery?
So I'm really sorry to mention this kind of information because when you working in the company, we have this called a non-disclosure agreement. So we are not allowed to mention their names if they give the permission. For example, there's a one company, CNOC, they give the permission to us, and some of the SPE paper, they give us the permission. But you can see we are currently in different stages with almost with all the big operator. So now you can see like all the big operators around the world. We are in contact. But because of the NDA, we are not allowed to share the names actually. But we are in contact in different stages to implement and of this project with all the big operator and small operator around the world. Yeah, but mostly we have currently in Middle East, North Sea, US, Canada, Asia, which is Malaysia, and Pakistan, and nothing in Africa for right now, but we are in contact with some of the different local operator. So I hope you will understand. This will help.
Sure, sir. And if you want, you can go through Google, you can search Angelus. So next question from Nandar. Sir, which one will be more environmental friendly? Organic oil recovery or green zyme enhanced oil recovery? Since both of them are used with the same aim of enhancing oil recovery with environmental friendly, but which is more friendly? OOS and green
Okay.
zyme EOR.
So actually, basically, if some of the people, they don't know the green enzyme EOR, so this is a company. It's based in US, and it's called Med McKinsey, and they are using this technology. It's called green enzyme EOR. So I'm not really sure that how much environmental friendly their product are, but basically we are very different from each other. I'm not sure about that one because I need to go and check that one. I hear about that one, but I didn't check their company profile and stuff like that. I don't know how much environmental friendly they are, but what OOR is 100% environmental friendly, which I already mentioned. They have no dispose issue. Even you can dump into the North Sea, which is the very they have like a lot of environmental regulatory there, and we have certificates, environmental certificates from the UK and Norway for this nutrients, which we have the permission basically to dump this to the North Sea. But the enzyme EOR, I'm not really sure how much environmentally they are, but what I know, they are using enzyme for their recovery. So there's a lot of other EOR method also, like chemical and thermal and stuff like that. But of course, they are not coming to environment because it's a chemical. Regarding the enzyme, I'm not really sure actually. Maybe you can Google it, how it that one. But I can give you information on organic oil recovery. So organic oil recovery is, you consider it as a fish food. So they have like no environmental effect actually. If you can dispose this to the North Sea, you can dispose this everywhere in the world.
Thank you, sir. Next question. I think there are no more questions from the participant. And participant, if you have any question, you can just either raise your hand or you can type in the chat box. It's better you can raise hand so that you can interact with Taj sir. Anyone? Okay, so no one interested or no one has any questions.
In case if you guys have still any question, I mean later, or maybe you can approach us through LinkedIn, or either way you want, you can send your question to, and then they can email us, and then we can come with the best answer.
Definitely. So I think no more question from the participant. So I would like Mr. Rahman to conclude this webinar session.
Okay, before concluding, I will just say my sincere thank you to Petroleum Engineer Association, and also PetroNile Academy from Sudan, and Abdurrahman, Mr. Yasir from Sudan, and Nahil Agarwal from India. Thank you so much for all these organizing this event, and hopefully we will have more in future. Thank you so much.
Thank you so much, sir. Thank you so much. Pleasure is all mine. So, Mr. Rahman, please conclude the session.
Thank you, Mr. Taj Uddin, for this fantastic webinar. I hope everyone had a great ride with us. And thank you, of course, to the Petroleum Engineering Association and Mr. Nakhil. So I think that's it for today. And thank you to all our attendees. This session will be soon available on the YouTube channel of both of PetroNile Academy and the Petroleum Engineering Association. So you can access it at any time. Now stay safe. See you soon in future endeavors, and goodbye. Thank you all.
Thank you so much, Mr. Rahman, and thank you so much, Mr. Taj Uddin, sir, for
Thank
your
you.
wonderful presentation. Hope the participant enjoyed this knowledge session. So thank you so much, participant, and thank you so much, sir, for your precious time. Now I would like to thank my team members and every participant for joining with us. So you can, and participant, I saw 1-2 questions regarding certificate. So I would like to tell that there will be no any certificate of participation for this webinar. This is just a knowledge sharing session. And yeah, if you want recorded videos, you can find in our YouTube link, YouTube channel. So thank you so much, sir, and thank you so much, participant. Have a nice day ahead, everyone.